Good morning, mathematicians. Go ahead and grab your notes. Today we're going to be talking about geometric sequences. Don't forget to write today's objective. So jumping in today, like I said, don't forget to write your objective. We're going to be talking about geometric sequences. So we talked about arithmetic sequences, and now we're moving on to a different type of sequence, a geometric sequence. And our goal is to be able to find the missing term in that geometric sequence. So first things first, what is a geometric sequence? It's a sequence where each number differs from the previous by a constant ratio. You multiply to get from one term to the next. So if we're thinking about arithmetic, we know that we add or subtract to get from one term to the next. Geometric, we multiply to get from one term to the next. So here is a couple examples. We have the first sequence, 3, 9, 27, 81, and you can see it continues. And then our second sequence, 52, 26, 13, and 6.5. So I want to look at how am I moving from one term to the next, and that should be a consistent ratio. And on this one, from 3 to 9, I know that that is being multiplied by 3. 3 times 3 is 9. And on the second one, I can check that again. 9 times 3 is 27. So I know that this is my common ratio. This is the number I am multiplying by to get from one term to the next. If I did 27 times 3, I would get 81. And if I wanted the next term, I would multiply 81 by 3. On the bottom, we can also check it down here. But we can see on this one that this sequence is going down. So as before with arithmetic, we had addition whenever we saw the sequence increasing. We saw subtraction whenever the sequence was decreasing. With geometric, when the sequence is increasing, we see multiplication. And then whenever it is decreasing, we are actually dealing with division. So we can see 52, if I divide that by 2, I get 26. And then again, with 26, if I divide that by 2, I get 13. And if I divide 13 by 2, I get 6.5. If I wanted the next term, I would divide 6.5 by 2. So just keep that in mind. Multiplication and division are opposites. So we want to make sure that when we're dealing with geometric, we are either multiplying to increase or dividing to decrease. But you'll notice that in the geometric sequence, it does say you multiply to get to the next term. When we're talking about the common ratio, which is this number that you're multiplying by, that needs to always be in terms of multiplication. So if you notice that a sequence is dividing, meaning that it is decreasing, it's going down, what actually is happening there is you're multiplying by that fraction. So instead of dividing by 2, I'm multiplying by 1/2. And again, instead of dividing by 2, I'm multiplying by 1/2. It's the exact same thing. You can check it in your calculator. 52 divided by 2 is 26. 52 times 1/2 is 26. They are the same thing. All right, so I've been throwing around this word common ratio, but what does that actually mean? So a common ratio is the number you multiply by in order to get from one term to the next, which is the ratio between each term. So like we saw here, 3 would be my common ratio whenever I'm talking about that first sequence because it's increasing by a multiple of 3 each time. And 1/2 would be my common ratio whenever I'm talking about the bottom sequence because I'm decreasing by half each time the number's being cut in half. Now, this is the reason that we have to always put our common ratio in terms of multiplication, because when we jump into the formula later, it always needs to be in terms of multiplication. Otherwise, the formula will mess up. And you'll see what I mean by that in a minute. But first, let's get some practice. I want you to pause the video and try to figure out what the common ratio is for each of these sequences before you come back. Okay. So now that we are back, let's see what the common ratio, I already gave you the answer, my bad. Let's see what the common ratio is for this sequence. So as I'm moving from 2 to 10, and then from 10 to 50 and 50 to 250, I can see that that is a multiple of 5. 2 times 5 is 10. 10 times 5 is 50. 50 times 5 is 250. So I know that my common ratio, or R, that is the letter we use to represent common ratio, is equal to 5. Now on the second one, I can see that we have 54 to 18 to 6 to 2. So I notice that's going down. So right away, I know that's going to be division. And it looks like I'm dividing by 3. Yep. So I'm dividing by 3, or I would like to put that in terms of multiplication. So I would say I am multiplying by 1/3. And if you are ever confused about getting your fraction, just like with arithmetic sequences, you can always take a term and just divide it by the term that came before it. So 2 divided by 6 is 1/3, 6 divided by 18 is 1/3, 18 divided by 54 is 1/3. So here our common ratio, or R, would be 1/3. And now we have our geometric sequence formula. This is the reason why it's so important that we make sure that our R is in terms of multiplication. Because if you put that R is divide by 2, it won't work whenever we are doing this formula. So let's break down this formula into bit by bit. Hopefully some of these variables look familiar. So we have our first variable here, UN, which we know is the value of the term or the general term. It's just the formula. We have U1, which is our first term. New letter here, we have R, which we talked about. It's the common ratio, what we are multiplying by. And we have N, which is the location or the number of terms. So if I'm looking for the 5th term, the 7th term, the 8th term, that goes into N. All right, let's look at this example. So we are given a sequence, 2, 10, 50, 250, just like from before. So if I want to write that general term, I'm going to start by writing down my formula. UN is equal to U1 R to the N minus 1. And the first thing I want to do is figure out what my first term here, my first term is. So as I'm looking at that sequence, my number that's in very first place is 2. So I'm going to swap out that U1 and put a 2 instead. And now I want to figure out what my common ratio is. Just like before, I can see that this sequence is moving by a multiple of 5. So I'm going to go ahead and switch out R for the number 5. And that is my general term. Those are the only two things I need to switch out. Now this formula is ready to go, and I can find any term that I want with it. So we're going to use the formula to solve for U2. Now, we know that U2 means the second term or location 2, and I can see from right up here that the second term is 10, but I want to use the formula just to double check. So I'm going to put U2 is equal to 25 to the 2 minus 1. And if I put that into my calculator, I can see that U2 is 10. And let's go ahead and do it with U3. Again, looking at U3, I can go get that answer directly from my sequence. I know that that is the third term, which in this case is 50, but let's see how we would work it with the formula. So plugging in 3 now for our N, I'm going to get U3 is equal to 2 parentheses 5 raised to the 3 minus 1 power. And I plug that into my calculator, and I do indeed get 50. So now you can kind of see how this formula is working out. We have our general term, which is where we just have UN and we have N in place. And then anytime I want to find a term, I'm just going to take whatever term I'm looking for and I'm putting that in place of my N. So what if we wanted to find a really big term like U sub 20? We've talked about this before with arithmetic. You can just continue the sequence over and over again. That's fine, and that works out for some. But when we're talking about IB problems, we're definitely going to want to be showing our work and showing that we know how to use the formula. And also with problems like this where you have U20, that's the 20th term. That's a very long ways down the line. And we want to make sure that we have a shortcut to get there so we're not just constantly multiplying by 5 over and over again in our calculator. So I'm going to grab my formula again, switching out N and inputting 20. And then when I put that into my calculator, you're going to see that you get a really big number. My calculator didn't even give me the full number because it was too big. It gave it to me in scientific notation. That's how big it is. So I got 3.81 times 10 to the 13th power. So if you remember back to our first unit when we talked about scientific notation, that'd mean we'd have to move that decimal 13 times to get that very, very, very large number. When we're dealing with geometric sequences, it's very common for terms further down the line to be in scientific notation because geometric sequences increase very rapidly and they decrease very rapidly. So if you get a number like this, if you're talking about the 20th term, the 15th term even, or somewhere down the line, don't worry, you didn't mess up. It means you probably did it right. All right, I believe that that is our last example for our notes. You are ready to go ahead and jump into the practice for today. Let me know if you have any questions during class. Bye, y'all.